Okay, guys. So you're talking about this thing. This we call error bar. Now, for example, there is a data set in which there are marks for 10 students. And okay, and the marks, let's say, are 20, 30, 50, 35, 40, 85, 100, 90, and 60. So let's say these are the marks. Now, as you can see, this is a three-dimensional graph because one dimension is this, one dimension is this, and then this is also giving some information. So basically we have three variables over here. Now that's an interesting three variables over here. So now one being this, second being this, then obviously third is something about this axis. So basically this bar is derivation of this axis. So if we have to plot this on a bar chart, we need to know what we need to keep on x-axis and what we need to keep on y-axis. So this is what we can do. We have to create periods of marks because it's a so now the periods of the marks would go, for example, it's out of 100, so 20, 40, 60, 80, 100. And we know the minimum marks is more than 10, so let's say one period is 10 to 30, in which we include the border points. So 10 to 30. Next would be 31 to 50. Next would be 51 to 70, 71 to 80, 90, 91 to 100. Okay. And how many students actually have marks between 10 and 30? We see student number 2 because it's 20. We don't have anyone between. Oh, we do have 20 and 30. So basically 2 students. We'll just mark it so that we know we have counted this already. So there are 2 students between 10 and 30. Then between 31 and 50, we have 35, 40 and 50. We have 3 students. So 35 and these are 4, 5, 6. Now between 51 and 70, we have a student number 1. And that's it. We have student number 1. Okay, there is one more missing, so let's keep 51. Let's keep someone with the mark, say 55. See, this data set I came up just now, so there might be some mistakes over here. So there are 3 students between 31 and 50, which is 35, 40 and 50. Now between 51 and 70, we have 55, we have 60. So it is student number 10 and student number 1. 2 students. Now between 71 and 90, we have 71 and 90, we have 85 and 90, which is student number 7 and student number 9, which is 2 students. And then between 91 and 100, we just have 1 student, which is student number 8. So this is how we have created the frequencies. Now to plot this, we are going to use an easy criteria. No one is going beyond 5. So let's say 1, 2, 3 and 4. Now between 10 and 30 there are 2 students, so we are going to keep it like this. 3150 we have 3 students, so we are going to keep it like this. 51 to 70 we have 2 students, we are going to keep it like this. 71 to 90, 91 to 100 we have 1 student, we are going to. This is the basic bar chart we have come up with. Now we want to plot this variance. Now what is the mean of all these numbers? I should have thought before considering the data point. So 60, 20, 80, 80, 30, 110, 110, 160, 160, 185, 185, 225, 225, 310, 310, 410, 500, 555. So 555 looks out to be the sum of all this. 80, 110, 160, 195, 85, 75, 81, 95, 95, 235, 240, 320, 420, 510, 565. I'll do it third time. 80, 30, 110, 160, 195, 235, 320, 420, 510, 565. So 565 is the sum of all these quantities divided by 10. Comes out to be 56.5 is the mean. So mean is 56.5. Now the students whose marks are between 10 and 30. 2 students. I should have done marks as well. 10 and 30 we have 20 and 30. 20 and 30. These are 2 students below the mean. So we are going to simply, and let's say this error bar, this is basically the upper point, this is the lower point in that particular data set in that period, and this is basically the mean. So in this case both the points are under the mean, so something like this would come out. Now between 31 and 50 we have 3, but we know all 3 are below 56.5, which is whatever, so we are going to keep it like this, but the length of this would be slightly bigger than this because there are 3 students in it. Now 51 and between 51 and 70 we have 2 students. 51 and 70 we have 2 students, and 56.5, so one is 50 and other one is 55. Both are less than 56.5 somehow, so it's going to come like this. Now these 3 cases both are bigger than this, then this come like this. Now you must be thinking that why don't we have in the periods something looking like this? That's because somehow the data set which I've taken have made me come up to this conclusion. Let's say if we have a data set, for example, for each class, for example, let's say I talk another. So class A, so this is the class A, B and C, and then their marks, mean marks of each class, let's say comes out to be 50. I'm just mugging up numbers. 50, let's say this is 55, let's say this is 52. And in class A there are 3 students, and each class have 10 students in total. Class A there are 3 students less than the mean marks and 7 students more. In class B there are 5 and 5, and in class C there are, let's say, 6 and 4. Then the histogram which might come out for class A, B and C. First of all, we are going to plot the marks of, let's say, like this, something like this. So we know the mean is 50 in class A and 3 students are in the lower range and 7 in other, so it will come like this. Now in class B, 5, 5, in class C 6-4. This graph is somewhat similar to this. If you remember, we studied this as well. Like this. Where this is the mean value, this is the count of the students lower than the mean value, and this is the count of the students more than the mean value. So these both graphs can be used to represent the same thing. That's what I understood from this. Thank you.